Hello everyone. Today we are going to look at a method called Thomas algorithm that can be used to solve a system of linear algebraic equations that are in tridiagonal form. So the objective is to solve a system of linear algebraic equations in tridiagonal form. That means we have non-zero elements present in the diagonal elements in the upper diagonal locations and the lower diagonal locations. The rest of the places we have zeros present in our matrix. This is shown over here. So the system of linear algebraic equations is given as A times x equals b, where A is the matrix, n by n matrix, where n is the number of rows or the column, and x represents the unknowns and b represents the column vector. So the tridiagonal matrix is shown here, which is represented by A. We have, as mentioned before, non-zero numbers along the diagonal locations. Typically these values are the same. Likewise, along the upper diagonal and the lower diagonal locations also we have non-zero values. In the rest of the locations on this A matrix, we have zero value elements. So the above set of equations we can efficiently solve using Thomas algorithm. The previous matrix A, for example, is arranged as here. This is the original A matrix, which is 7 by 7 here, and we ended up with 7 by 3. So we have basically eliminated 7 by 4 element locations in the matrix. So on the left hand side of this matrix, basically in column 1 represents the lower diagonal elements, and the middle column, which is column 2, represents the main diagonal elements, and the right hand column 3, represents the upper diagonal elements. The algorithm is represented over here, where D represents the main diagonal elements, and L the lower diagonal elements, and U the upper diagonal elements, and B represents the right hand side vector. And this is the algorithm for obtaining the solution. And we'll go back to MATLAB and find out how we can get those solutions. So this is the MATLAB program for Thomas algorithm. The combined matrix AB, which includes the main matrix, the main A matrix, as well as the column vector B. They are combined together. And we'll run this. Once we run this, there is a combined matrix AB, and then the number of rows, number of rows n equals 7 in the A matrix, and this is the A matrix, which is in tridiagonal form, and B represents the column vector here, and we rearrange the A matrix in this form so it can be solved easily and efficiently, and the solution is obtained when we utilize the algorithm presented in the PowerPoint. And when we compare the solution to the solution obtained using the built-in function in MATLAB, which is A \B, they pretty much match. So x1 over here is negative 1.9668 and x2 is negative 4.4252 and so on. The last one is negative 60.9237. To summarize, in this video we presented a procedure called Thomas algorithm to solve a system of linear algebraic equations. Please note that we can only solve those equations when it is presented in a tridiagonal form. The advantage of Thomas algorithm is that the method is very efficient. We don't need a lot of computer resources to store all the zero values existing in the non-tridiagonal locations. In the next video, we'll show you how to solve linear algebraic equations using iterative methods. If you have any questions, please post it. Thanks for watching the video.